The data from Hawaii's Gemini Observatory was never meant to go public. What began as a routine observation of an interstellar comet has now ignited panic behind closed doors at NASA because what the Gemini team detected shouldn't exist. Not if 3I Atlas is truly a natural object. Something else is moving with it, something coordinated. If these readings hold true, we're not looking at a lone traveler. We're watching a system at work. The new Gemini observations didn't just sharpen our view of 3I Atlas, they redefined it. Across multiple exposures, astronomers identified several smaller luminous points following the main object, each holding formation with uncanny precision. At first, the explanation seemed simple: debris, fragments, maybe even camera noise. But every mundane theory collapsed under scrutiny. Independent teams reanalyzed the raw data, and the same pattern emerged. These weren't lens flares, not cosmic rays, not optical ghosts. They were discrete, verifiable companions, each moving in perfect synchronization with the comet's velocity vector. Gemini's instruments, capable of detecting single photons across deep space, confirmed a reality too structured to dismiss as coincidence. Multiple points of light, stable, aligned, deliberate in their behavior. Even amateur astronomers, thousands of miles apart, recorded the same faint procession across the night sky. And yet, the more data collected, the more unnatural the picture became. These companions didn't drift, spin off, or fade. They held their line as if bound by an invisible geometry. Nature scatters chaos, but this moves with discipline. If 3I Atlas had fragmented naturally, we'd expect chaos. Pieces tumbling away on diverging paths, each fragment spinning erratically, scattering dust and vapor in unpredictable plumes. That's what physics demands, but that's not what we're seeing. Instead, the supposed debris remains locked in near-perfect formation. Their separation distances barely fluctuate. Their light curves, the subtle pulse of brightness each body emits, remain synchronized as though they share a single internal rhythm. Amateur astronomers across the globe have confirmed it. In Germany, Chile, Japan, and the American Southwest, independent telescopes have captured the same impossible ballet, multiple luminous points traveling together, never breaking rank. Even a brief green flash appeared in several recordings, a strange diffused glow separate from the main body. At first glance, that color seems familiar. Green is the hallmark of comets rich in dicarbon, or C2, fragile molecules that fluoresce under sunlight. But spectroscopy tells a different story. 3I Atlas contains almost no C2 at all. It's chemically depleted of the very compounds that should produce this glow, and yet it shines that same ghostly green. The light behaves as though obeying chemistry that shouldn't exist, a wavelength without a source, a signal without an origin. Every model breaks the moment you try to explain how it maintains both order and color. The universe doesn't do choreography, and it certainly doesn't fake molecular emissions. A comet shining with the color of life, but without the ingredients that make it. By all natural logic, 3I Atlas should already be gone. 2 weeks ago, it endured a direct blast from a coronal mass ejection, a surge of charged solar plasma, powerful enough to vaporize or shatter any loosely bound object. Every model predicted catastrophic breakup. Yet when the storm cleared, Atlas remained intact, its rotation unchanged, its luminosity steady. That level of structural integrity is quite literally unheard of in cometary physics. Natural comets are fragile, porous snowballs of dust and ice, held together by little more than frozen gases. But Atlas doesn't behave like a snowball. It behaves like a shell. Recent modeling from independent researchers suggests a hollow or layered geometry, where internal symmetry distributes stress evenly across its surface, a shape designed, intentionally or not, for endurance. Hollow objects, when spun precisely, can maintain stability under extreme forces while regulating internal temperature through resonance. The implications are staggering. A hollow body reduces mass dramatically, allowing for faster travel and less energy loss. It protects whatever lies inside from radiation and heat. And if the structure possesses thermal buffering, some method of channeling energy through its surface, it could even regulate temperature intelligently, maintaining equilibrium in conditions that should destroy it. To call that engineering might seem premature, yet mathematically the idea fits. The physics align too neatly for comfort. The ratios of reflectivity, density, and rotational inertia suggest not randomness, but refinement. Scientists won't say it publicly, but the pattern is there. A natural body behaves within limits. 3i Atlas ignores those limits entirely. We can't prove design. We can't claim intent. But every new observation drags this object further away from the realm of accident and closer to the realm of architecture. No one's calling it a spacecraft, but physics keeps acting like it is. When NASA's Swift Observatory turned its instruments toward 3i Atlas, scientists expected quiet readings. At 3 astronomical units from the Sun, roughly 280 million miles away, comets are frozen solid, dormant, and still. Solar heat at that distance simply isn't strong enough to melt surface ice or trigger outgassing. But Atlas wasn't quiet. It was active. Swift detected a steady outflow of water vapor, nearly 88 pounds every second, venting into space with rhythmic precision. Not a burst, not a spike, a constant pulse repeating every few hours like clockwork. That kind of activity is unprecedented. Ordinary comets don't begin releasing gas until they cross inside the 2 astronomical unit threshold where solar radiation can penetrate the crust. For Atlas to be this active so far out implies something extraordinary. Either heat is being generated internally, or the comet's surface somehow channels and amplifies sunlight far more efficiently than any known material. Researchers have proposed natural explanations, perhaps hidden pockets of supervolatile ice or a porous structure conducting warmth deeper than expected. But the consistency of the emission breaks those models. Nothing natural maintains perfect rhythm under variable solar exposure. This isn't random thermal sublimation, it's regulation. The emissions rise and fall in smooth intervals as though governed by an internal process balancing input and output, a feedback loop. If the object is hollow, as some simulations suggest, this behavior could indicate heat cycling, energy absorbed, stored, and released in deliberate equilibrium, like a machine controlling its own temperature. And while the term artificial remains taboo in official reports, one fact stands unshaken. Atlas is doing something no comet should be capable of doing, maintaining activity where silence should reign. Something inside Atlas doesn't react to sunlight. It responds to it. If 3i Atlas were simply breaking apart, the math would show it. Fragments disperse. Their relative velocities drift with each orbit, scattering unpredictably across millions of miles. But what astronomers are tracking defies that chaos. Those smaller luminous points originally dismissed as debris haven't drifted. They've held their positions with unnerving precision. Each maintains nearly identical velocity and distance from the primary body, as if locked into a shared guidance equation. Over weeks of observation, their spacing remains constant within margins so small that even random gravitational interactions should have pulled them apart long ago. This has forced researchers to explore new frameworks, some elegant, others unsettling. One theory posits a natural form of orbital harmonics, that the fragments are caught in mutual gravitational resonance, adjusting their trajectories in real time, self-correcting like pendulums in perfect synchronization. But that level of coherence is statistically implausible without feedback, some kind of control mechanism responding to disturbance. And that's where the conversation shifts, because if these bodies aren't merely obeying gravity but managing it, maintaining relative spacing through coordinated microaccelerations, then what we're observing isn't debris at all. It's a formation. Imagine a convoy crossing interstellar space, each unit aware of the other, communicating not through light or radio, but through motion, trajectory as language. The void becomes their network. Every correction, every adjustment, a word in a geometry we can't yet read. Some call it poetic speculation. Others call it data that refuses to behave, because the further Atlas travels, the clearer the pattern becomes. These companions aren't separating, decaying, or deviating. They move as one. If motion can carry intent, what are we really observing? Is this celestial choreography a coincidence of physics or a demonstration of principles we haven't yet discovered? Science demands restraint, but philosophy demands wonder, because when you strip away the data and the fear, only one truth remains. Maybe we're not watching debris, maybe we're watching design. It's becoming a rhythm, a pattern written not in light, but in silence. In 2017, Oumuamua arrived, a slender, tumbling object that defied every model of natural motion. Within weeks, data streams slowed. Spectroscopic results went missing. Key papers were under review for months. 2 years later, in 2019, 2i Borisov swept through brighter, faster, but still inexplicably stable. Once again, the same thing happened. Images withheld, trajectories reclassified, entire data sets buried behind processing pipelines. And now in 2025, 3i Atlas repeats the cycle. Detection, wonder, then silence. NASA's public servers go dark. The European Space Agency delays its releases. China's Tianwen-1, usually prolific with Mars imagery, reports nothing. 3 discoveries, 3 pauses, separated by years, yet identical in choreography. Every time the universe offers something that doesn't fit, the instruments keep working, but the channels close. Officially, it's prudence. Verification before publication. Informational caution to avoid mass misinterpretation. And maybe that's true, but the symmetry is too precise to ignore. Every interstellar visitor invites a wave of awe, followed by an even greater wave of silence. Is it coincidence, bureaucracy, or the quiet recognition that what's being observed isn't just another rock, but something that bends the boundaries of comfort itself? History shows us that silence often isn't absence. It's signal, the kind you can't yet translate, but you feel in your bones. 3 interstellar messengers, 3 silences, and 1 unbroken pattern. Silence isn't always secrecy. Sometimes it's fragility. When faced with the unknown, humanity doesn't always conspire. It hesitates. The scientists staring at those Gemini frames, the analysts parsing radiation curves from Swift, the mission directors weighing every public statement. They're not suppressing the truth. They're afraid of mislabeling it, because in science, one wrong conclusion can echo for decades. It can collapse public trust, ignite hysteria, or bury genuine discovery beneath conspiracy. So the silence becomes a shield, not against knowledge, but against chaos. There's a line I often think about. It's, science doesn't fear the unknown, it fears the wrong conclusion. That's why every word about 3i Atlas is weighed, every release delayed, not because someone's hiding something, but because the implications might be bigger than anyone's prepared to face. It's easy to romanticize contact, to imagine revelation wrapped in clarity, but in reality, paradigm shifts arrive messy, uncertain, uncomfortable. Every great discovery begins with a pause, that breath between disbelief and understanding. So maybe the silence isn't censorship. Maybe it's reverence. Maybe for the first time the world's brightest minds are looking at something so far beyond definition that they'd rather risk ridicule than speak too soon. This isn't the end of curiosity. It's the test of it, because real science, the kind that dares to reach across interstellar darkness, isn't about having answers. It's about refusing to stop asking the hardest questions, even when the answers might unmake the world we know. The quiet right now isn't emptiness, it's anticipation, because the moment we stop asking, the universe stops answering. Maybe 3i Atlas isn't a visitor at all. Maybe it's a mirror, reflecting not what lies beyond the stars, but how little we truly understand. Every photon it reflects, every signal it withholds, reminds us that the universe still speaks a language we're only beginning to decipher. We thought we were the observers, the ones searching, measuring, naming them. But what if, this whole time, we've been the ones observed? The silence, the anomalies, the impossible precision, they're not answers. They're invitations, because discovery isn't a destination. It's a dialogue between curiosity and the cosmos, and maybe, just maybe, this is the first sentence in that conversation, because if this was NASA's hidden truth, what comes next will redefine the word discovery.